Good morning, everyone. Today's topic of discussion is respiration. Respiration is the process in which the respiratory substrate, that is the food we take, the most common respiratory substrate is a glucose, which is a carbohydrate. Formula of glucose is C6H12O. In the presence of oxygen, which we intake during the breathing process, is converted into carbon dioxide plus water, and the large amount of energy is released during this process. The amount of energy is equal to 686 kilocalories per mole or 2780 approximately kilojoules per mole. This amount of energy, that is 686 kilocalories or 2780 kilojoules per mole, released from one molecule of glucose is called as respiration. This energy is stored in the form of ATP, which is used to perform useful work. This whole process of respiration comprises of many steps. Number 1 is glycolysis. Number 2 is oxidative decarboxylation. Number 3, Krebs cycle or tricarboxylic acid cycle, or also known as TCA cycle. And number 4, the electron transport chain. So during the process of respiration, the glucose molecule C6H12O6, in the presence of 6 molecules of oxygen, is converted into 6 molecules of carbon dioxide plus 6 molecules of water plus 686 kilocalories of energy is released. This reaction takes place in steps. The first step is glycolysis, oxidative decarboxylation, electron Krebs cycle, and electron transport chain to produce the 686 kilocalories of energy. In case of glycolysis, which is also known as EMP pathway or Embeden-Meyerhof pathway, after the name of discoverer. In case of glycolysis, the glucose molecule, or more specifically alpha D glucose molecule, which is a respiratory substrate, by the various steps reaction is converted into 2 molecules of pyruvic acid. Is called as glycolysis. In a cell structure, The outermost layer is known as a plasma membrane, and in center there is nucleus, and the membrane is called as a nuclear membrane. The space between nuclear membrane and the plasma membrane is called as cytosol. In case of prokaryotes, for example, the organisms of kingdom Monera, and eukaryotes belonging to Protista, fungi, plantae, and animalia, the site of occurrence of glycolysis is cytosol inside the cell. So in the cell, in the plasma membrane, there are present the transporter of the glucose or gluc transporter, which helps in transfer of the glucose from the bloodstream inside the cell. So glucose goes inside the cytosol of the cell, and this glucose molecule, in the presence of enzyme called as hexokinase, is converted into molecule of glucose 6-phosphate. So the molecule of alpha D glucose this is structure of glucose molecule containing 6 carbon atoms, 12 hydrogen and 6 oxygen. OH, H, OH, H, H, CH2OH, H, OH, and on alpha position H towards the upper side and OH in the lower side on alpha carbon. This is known as alpha D glucose molecule. This alpha D glucose molecule, in the presence of an enzyme called as hexokinase, is converted into molecule of glucose 6-phosphate. So on the 6th carbon, 3, 4, 5 and 6th carbon, the OH or H is replaced by phosphorus. This makes the structure of glucose 6-phosphate, because in the 6th position there is an attachment of phosphate group. So in the cytosol of the cell, glucose 6-phosphate, this phosphate group provides negative charge, and due to this negative charge it cannot cross the lipid membrane, so it cannot be transported back to the blood. So it remains inside the cell. Mg2 positive and Mn2 positive act as cofactor during this process or during this conversion. This process of adding the phosphate group on the 6th position is termed as phosphorylation. So the conversion of alpha D glucose into glucose 6-phosphate, the process is called as phosphorylation. Phosphorylation. Glucose is 6 carbon compound and glucose 6-phosphate is also 6 carbon compound. This glucose 6-phosphate forms fructose 6-phosphate, structure of glucose 6-phosphate is converted into fructose 6-phosphate, which is a furan ring, CH2OH, H, H and OH, HOH, oxygen, H, CH2OH, OP. This sixth position, the phosphate group is attached, and glucose 6-phosphate is converted into molecule of fructose 6-phosphate, which is also a 6-carbon compound. The isomers are formed, and the process is called isomerization. So, conversion of glucose 6-phosphate into fructose 6-phosphate is called as isomerization in the presence of enzyme isomerase. In the formation of glucose 6-phosphate, the phosphate group is provided by the molecule of ATP is converted into ADP, and one phosphate group attaches to the 6th position, which forms glucose 6-phosphate. This fructose 6-phosphate then converted into, in the presence of enzyme phosphofructokinase, or PFK, fructose 1,6-bisphosphate. In case of fructose 1,6-bisphosphate, the phosphate group is attached to 1st as well as 6th position. So this addition of the phosphate group, this is molecule of bisphosphate. So in position number 1, H is replaced by phosphate. So this addition of phosphate group by phosphofructokinase is called as, again, phosphorylation. This fructose 1,6-bisphosphate in the presence of an enzyme aldolase this is also a 6-carbon compound. In the presence of an enzyme aldolase is converted into 2 molecules of 3 carbon each. The first one is called as dihydroxyacetone phosphate, and second is glyceraldehyde 3-phosphate. These both are 3 carbon. Total makes again 6 carbon. When the molecule of fructose 6-phosphate is converted into fructose 1,6-bisphosphate, the extra phosphate group is provided by molecule of ATP, which is converted into ADP and provide one phosphate group. This 686 kilocalories of energy in case of prokaryotes, it will form 32 ATP, and in case of eukaryotes, it will form 30 or it can form 32 ATP molecules, and the remaining amount of energy from the respiration converts into heat. Till now, in the glycolysis, one ATP is consumed over here and another ATP over here. So this whole phase of glycolysis, in which the only ATP are consumed, is called as preparatory phase. So alpha D glucose molecule at the end of preparatory phase form 3 carbon compound dihydroxyacetone phosphate, 3 carbon, and another molecule of 3 phosphoglyceraldehyde. In the presence of enzyme aldolase, this dihydroxyacetone phosphate can be interconverted in the presence of enzyme called as triose phosphate isomerase. So dihydroxyacetone phosphate can be converted into 3-phosphoglyceraldehyde. So 2 molecules of 3-phosphoglyceraldehyde can be formed from 6 carbon of alpha D glucose. This is glyceraldehyde 3-phosphate. Structural representation is CHO, CHOH, CH2OP. This is first carbon, second and third carbon. The phosphate group is attached, form glyceraldehyde 3-phosphate. This glyceraldehyde 3-phosphate is then converted into 1,3-bisphospho glyceric acid so glyceraldehyde 3-phosphate COOP CHOH CH2OP. First position as well as on third position there is no phosphate group. Now during this conversion, inorganic phosphate is not provided by ATP, it is provided by H3PO4 negative, which acts as a phosphate donor and forms 1,3-bisphosphoglyceric acid. Here on the first position, the phosphate group is attached to form 1,3-bisphosphoglyceric acid. This 1,3-bisphosphoglyceric acid is also a 3-carbon. Therefore, total 2 molecules are formed and 6 carbon are complete. This conversion is done in the presence of an enzyme called glyceraldehyde 3-phosphate dehydrogenase. When the hydrocarbons Hc are converted into alcohol, into aldehyde or CHO, into an acid COOH, to carbon dioxide CO2, the process is called as oxidation, and the conversion of carbon dioxide into acid, to aldehyde, to alcohol and then to hydrocarbon is known as reduction. So in this process, 3-phosphoglyceraldehyde, which is an aldehyde molecule having CHO group, is converted into 1,3-bisphosphoglyceric acid. Therefore, this is an acid COOH. This conversion of aldehyde to acid is known as oxidation. Therefore, there is oxidation of 3-PgAl to form 1,3-bisphosphoglyceric acid. During this process, 2 molecules of NAD are converted into 2 molecules of NADH. This molecule of 1,3-bisphosphoglyceric acid is converted into 3-phosphoglyceric acid, and during this process, from the first position, inorganic phosphate is removed, and this inorganic phosphate is captured by molecule of ADP and converted into molecule of ATP. As two molecules of 1,3-bisphosphoglyceric acid are used, so two molecules of ATP are formed. So out of 32 ATP in case of eukaryotes, 2 ATP are formed in this step. This process of formation of ATP during the metabolic process is called as substrate level phosphorylation or SLP. This conversion takes place in the presence of enzyme phosphoglycerate kinase. It is 3-carbon compound and 2 molecules are formed because 2 molecules of 1,3-bisphosphoglyceric acid were used. Now from 3-phosphoglyceric acid, the phosphate group is moved to the second position, which forms 2-phosphoglyceric acid. 2 molecules and 3 carbon. Structure of this 3-phosphoglyceric acid is COO negative, CHOH, CH2OP. In the third carbon, there is present phosphate group. Is converted into 2-phosphoglyceric acid. This phosphate from the third carbon moved to the second carbon, and the structure is COO negative, CHOP, CH2OH. Is 2-phosphoglyceric acid, 3 carbon. 2-phosphoglyceric acid then forms 2-phosphoenol pyruvate in the presence of enzyme called enolase. During this process, molecule of water is removed. COO negative, COP and CH2OH. This is 2-phosphoglyceric acid converted. H over here. COO negative, COP, double bond, CH2. During this process, molecule of water is removed. 2 molecules are involved, so 2 molecules of water are removed, and the enzyme is enolase. Mg2 positive and Mn2 positive act as cofactor during this process, which form 2 molecules of 2-phosphoenol pyruvate. This phosphoenol pyruvate in the presence of enzyme pyruvate kinase, removal of phosphate group, which is accepted by 2 molecules of ATP and converted into ATP 2 molecules, forms COO negative, C double bond O, CH2, CH3 sorry, called pyruvic acid. 3 carbon, 2 molecules are formed. This is complete glycolysis cycle in which glucose is converted into 2 molecules of pyruvic acid. In glycolysis, 1 molecule of alpha D glucose, 6 carbons by various steps reaction converted into 2 molecules of pyruvic acid, 3 carbon, total makes 6. As there is no carbon dioxide removed during this process, therefore in this process there is no decarboxylation. So in the summary of glycolysis, molecule of alpha D glucose, 6 carbon, converted into glucose 6 phosphate, again 6 carbon, process is known as phosphorylation. And this glucose 6-phosphate in the presence of enzyme isomerase converted into fructose 6-phosphate 6 carbon. Fructose 6-phosphate is converted into by the process of phosphorylation into fructose 1,6 bisphosphate, again 6 carbon. During the formation of fructose 6-phosphate to fructose 1,6 bisphosphate, ATP is converted into ADP, and during formation of glucose to glucose 6-phosphate, again ATP is converted into ADP. Enzyme used here is phosphofructokinase or PPI, act as a phosphate donor.
If somehow this phosphofructokinase is defected, PPI serves as phosphate donor.
This type of having the alternate pathway in case of plant is called as metabolic reductancy. Like if phosphofructokinase is defected, PPI takes its role. During this process, 2 molecules of ATP are consumed, and this phase is known as preparatory phase. This fructose 1,6 bisphosphate in the presence of enzyme aldolase is converted into dihydroxyacetone phosphate 3 carbon and 3-PGAL, again 3 carbon. These two can be interconverted in the presence of enzyme triose phosphate isomerase. So dihydroxyacetone phosphate can be converted into 3-PGAL. Therefore, 2 molecules of 3-PGAL are formed. This 3-PGAL in the presence of enzyme phosphoglyceraldehyde dehydrogenase converted into 1,3-bisphosphoglyceric acid. During this process, 2 molecules of NADH are formed. This 1,3-bisphosphoglyceric acid in the presence of enzyme phosphoglycerate kinase forms 3-phosphoglyceric acid, and during this process 2 molecules of ATP are converted into 2 molecules of ATP. This 3-phosphoglyceric acid is converted into 2-phosphoglyceric acid, two molecules, because 2 molecules of 3-PGA were used. This 2-phosphoglyceric acid in the presence of enzyme enolase, 2 molecules of water are removed, form 2 molecules of phosphoenol pyruvate. This phosphoenol pyruvate 3 carbon in the presence of enzyme pyruvate kinase form pyruvic acid 3 carbons and 2 molecules. Here 2 molecules of ATP are formed by phosphoglycerate kinase and 2 molecules of ATP are formed by pyruvate kinase. In these steps, total 4 ATPs are formed. So in the steps where ATP are formed is known as payoff phase. So in case of glycolysis, 2 molecules of ATP are consumed and 4 molecules of ATP are formed. Therefore, net gain is equal to 4 minus 2 to ATP. These 2 ATP are formed by substrate level phosphorylation, also known as SLP. Two molecules of NADH are also formed during this process. One molecule of NADH will form 2.5 ATP, therefore 2 will form 5 ATP. This is 6 molecule of oxygen. So in glycolysis, 2 ATP formed by SLP and 2 NADH. This 2 NADH will form 5 ATP. Therefore, in glycolysis, total 7 ATPs are formed. So out of 32 ATP, 7 are formed during glycolysis. In case of prokaryotes, 7 ATP are formed. So inside the cell, this is nuclear membrane, plasma membrane. In the cytosol, two molecules of NADH are formed. In case of prokaryotes, there are no cellular organelles. So total 7 ATPs are formed. But in case of eukaryotes, glycolysis takes place in cytosol. In eukaryotes, two molecules of NADH forms ATP during electron transport chain. This electron transport chain is present in inner mitochondrial membrane. So glycolysis occurs in cytosol. So in a cell, this is nuclear membrane, plasma membrane, and the region between nuclear membrane and plasma membrane is called as cytosol. These two NADH formed in cytosol. To form ATP from NADH, these must be transported to inner mitochondrial membrane. Mitochondria is a bilayered structure, consists of outer membrane and inner mitochondrial membrane. These two NADH will have to go inside or have to cross the inner mitochondrial membrane. These NADH moves from cytosol to inner mitochondrial membrane, and they can be transported in the form of NADH or can be transported in the form of two molecules of FADH2. One molecule of NADH will form 2.5 ATP and one molecule of FADH2 will form 1.5 ATP during the electron transport chain. If this is transported as NADH, it will form 5 ATP plus 2 ATP from SLP. Total makes 7 ATP during glycolysis. And if these are transported as 2 FADH2 molecule, one FADH2 will form 1.5 ATP and 2 will form 3.0 ATP. Therefore 3 plus 2 total makes 5 ATP. If FADH2 is involved, it will form 30 ATP, and if NADH is involved, it will form 32 ATP at the end of respiration. In prokaryotes, cellular organelles are absent. Therefore, the total ATP formed are always 32. Glycolysis. Total 7 ATPs are formed, or 5 ATPs can be formed if FADH2 is involved. So one molecule of alpha D glucose converted into 2 molecules of pyruvic acid. During this whole process, total of 7 ATPs are formed. As whole of the glycolysis occurs inside the cytosol, therefore 2 molecules of pyruvic acids are also formed inside the cytosol.